So I have a fun little demo here for you. This is a Tesla coil. Basically, a whole bunch of wires wrapped around. The Tesla coil, attach it to the wall outlet. We have because it's connected to the wall outlet, the current through that coil is alternating with time. It's an AC current because the wall outlet is an AC power source. So what's happening is this alternating current is creating a magnetic field that's alternating with time, which in turn induces an electric field. And it behaves similar to our Van de Graaff generator. And that electric field emanates from the ball of the Tesla coil. Turns out that alternating magnetic field can induce an electric field in any sort of conductor. So these are just my keys. Because it's a conductor, that electric field that is induced can exert a force on the charges and they can physically jump from the Tesla coil to my keys. And that's when we see the spark. It's ionizing the air as it jumps. And it actually, you can smell it up here. The difference between the Van de Graaff and the Tesla, though, is that the induced field over here is alternating with time as well. So any sort of current you get, like in my key, is going to be alternating with time as well. You can shock yourself. I prefer not to shock myself though, so I don't have to. Another really cool thing, I have gas tube. This is just like our fluorescent tubes, only it has only one type of gas in it. I'm not sure what type of gas it is. The label fell off. So that alternating magnetic field is creating an alternating electric field, which is creating a potential difference here in the fluorescent tube. If I hold the tube down here, only the lower portion will light up, because I'm a conductor and the current flows through me. If I want the whole tube to light up, I have to hold it at the other end. So we can induce a voltage in here, which in turn causes our lights to light up. So kind of fun. So Maxwell was actually a really big player in understanding this generation of electromagnetic waves. And understanding that if we generate an electromagnetic wave that's alternating here, we can induce an alternating electromagnetic wave in another object, which is how antennas work, how our radio broadcast stations end up playing music in our cars or in our homes. So it was actually a really big step in our history here. So just a fun little one. If I get it close enough, I do get sparks. The charges will physically jump. But if I get farther away, the charges can't jump. The force on them isn't big enough. But it's still inducing that electric field, which in turn is inducing a voltage. Now, the farther and farther away I get, the less of an induction we get. And that's because the field gets weaker and weaker the further away we get from this. So, just a fun little demonstration.